Hello guys, this is another lecture on cantilever with point load not at the free end. So here is the diagram showing the geometry of the figure. So in our previous lecture we talked about cantilever with point load at the free end. So the difference is just little from this. So this is Macaulay tutorial. Like, subscribe, watch and comment on our video. If you have any question, feel free to ask on our channel. So let's proceed into today's class. So this is a cantilever beam having its point load at a distance away from the free end W. Then the total distance is L. Then the distance from the point load to the fixed point, I labeled it L1. Then this is the line showing the deflection. It will have a deflection at point YC, which is deflection at point C, and we also have a deflection at point B. So at point B, this is the maximum deflection. So we labeled it A, C and B. So when it deflects at this angle, we call this place after the deflection, we call it C prime. Then at the maximum deflection, we called it B prime. So this is the angle of the slope. So this is a small note I wrote out for explanation of the diagram. AC of the cantilever will bend into AC prime, while the portion CB will remain straight and displayed to C prime B prime. So portion AC of the cantilever may be taken similar to having cantilever having load at the free end. And in our last class we did cantilever with point load at the free end. So what we derived for the slope and the deflection, the maximum deflection for cantilever with point load at the free end, which is this, we will write out the derivation, what we got as our final answer for slope and deflection. So here guys, so this is for slope. We got it as WL. This L1 means the small distance from C, that's slower. This is slope at C, so L1, WL1 raised to power 2 over 2 EI. So the slope angle is the same thing. The slope angle at point C is the same thing with the slope angle at point B, where we're having the maximum deflection. So which is also equals to WL1 raised to power 2 EI. So in radians, in rad. So the maximum deflection that we got for cantilever with point load at the free end in our previous lecture was this. This was what we came about. We solved WL1 raised to cube of 3 over 3 EI. So from the geometry of the figure, please, I will advise you to make sure you put something down and follow the procedure on how it is being solved and explain. So at YB, where we're having the maximum deflection, maximum deflection, we're having two deflection. So we're having the maximum deflection here at point B, and we're having one deflection here at point C. So we want to get the deflection at point B. So how do we do that? So we proceed to solving it. That will be YB equals deflection at point C plus the slope at point C. I told you that the slope at point C is the same with the slope at point B, so you just pick one of it, times the L minus L1. That means the total distance minus the small distance away from the fixed end. So YC is this WL1 cube over 3EI plus the slope at point C, WL1 raised to power 2 over 2EI, then into brackets L minus L1. So here we assume that L1 is equal to is equal to L over 2. So any place you see L1, you substitute L over 2. So here we substitute it. In this place I'm supposed to substitute L1 here. I already did that here, so but I already covered my error here. So maximum deflection here equals W into brackets L over 2 cube, then 3EI, that will be times 1 over 3EI, still the same, plus WL over 2 square all squared times 1 over 2EI into bracket of L minus L over 2 close bracket. Then we resolve it to this. So deflection at B is now this. When you multiply everything together, WL cube over 224EI plus WL square over 8EI into the bracket of L over 2 close bracket. So when we multiply it, we resolve it to be this. Then what is the lowest common multiple? What is going to 48EI? So you do this, then you get deflection at point B to be this 5WL cube over 48EI. So this is the deflection, the maximum deflection at point B for cantilever with point load or concentrated load, not at the free end. So when we apply it, our unit is in millimeter, while for slope our unit is in radians. So in our next class we'll be talking about cantilever with a UDL load. Thank you. God bless you. Do remember to like and subscribe to our video to receive notification of new videos that will be uploaded. Thank you.